Welcome. Thank you for coming. In this session, we are going to see a little bit of history of the HTTP2 protocol, or the HTTP protocol, and then the evolution that went from HTTP 1 to HTTP 2, and the implication that this evolution has brought to our ecosystem, the Java ecosystem, and in the way we develop web applications and we deploy web applications. So this is me. I work for a company called Webtide that provides support for Jetty. I wanted to mention this because this year is the 20th anniversary of Java, but it turns out there is also the 20th anniversary of the Jetty project. It was started like in '96, end of '95, as a issue tracking system by Greg Wilkins, and this year is also the 20th anniversary of the Jetty project, which is probably the oldest open source project in Java around, or one of the oldest. So we are still kicking ass, so follow me on this presentation because it's going to be awesome. So why HTTP2? This is a very good question, and this is the answer. This is the page of the w3c.org in '96. It was a single HTML file for 600 bytes only, and this was the page. It was very simple. '96 was also the year that the HTTP 1 protocol was standardized, and because the pages and the web was this web, the HTTP 1 protocol was designed to serve this kind of pages, okay? Fast forward to 2015, and this is the same page of the w3c.org, but now it downloads 41 resources, and it's not 600 bytes, but 366 kilobytes. So there has been an increase of 40 times in number of resources that have to be downloaded, and an increase 60 times of the number of bytes that needs to be downloaded. As you can see here, it's much richer. One HTML file, 4 CSS, 2 JavaScript, 34 images, right? Now, the cool thing about all this is that this page is not even close to the average page of the web today. This is the CNN.com page. It's a whopping 95 resources for 6.7 megabytes of download, okay? And it's 3 HTML files, 4 CSS, 30 JavaScript files, and 58 images, okay? This is the web of today, and the question that we should ask ourselves is the HTTP 1 protocol still the right protocol to use for today's web? Or do we need an update of the protocol after almost 20 years of HTTP 1? All right? And these were the questions that HTTP 2 was, answering. So what happened in these 20 years? That the web exploded. But HTTP 1.1 is an old protocol, is inefficient, is extremely inefficient for today's web. There is no multiplexing, no resource correlation, and we'll see in a second what these two terms mean and why they are so important for today's web. Web developers started to hack around HTTP 1 limitations. Who in the room here knows what is domain sharding? Okay, a few of you. Who knows what is image spriting? Many more, okay. So these two are considered today as best practices. If you go around and Google for those, they're considered best practices. They're not. They are just workaround for limitation of the HTTP 1 protocol. If the protocol was better, you didn't need to do these workarounds or best practices. Why is that? I'll go into that in a second. So browser vendors, Chrome, Firefox, Internet Explorer, wants to make the browser super fast. They want to be able to render the page as fast as possible to improve the user experience. And there's been like a race to become who's the fastest browser around, right? And in order to achieve this goal and being the fastest browser around, they are breaking HTTP 1.1 recommendation. So one of these recommendations is you can only open 2 connections on a single domain. That's what the HTTP 1.1 protocol says. However, browsers do not respect that and say, oh, well, if I open only 2, then it's going to be a lot of round trips to download my CNN.com page, because I have to do 95 downloads. So it's like, OK, let me open 2 connections, make 2 requests, wait for those 2 requests to come back, then make another 2 requests, and then come back, another 2 requests, and come back. And by the time you arrive at 95 requests made to that server, then a lot of time has passed, and the page doesn't render fast. So browsers break this. They open 6 connections to a single domain. And that's where domain sharding comes in. Domain sharding is a trick. Instead of requesting your resources to .domain.com, you split your resources in a way that you put your images into images.domain.com. So the browser can open 6 connections to images.domain.com, can open 6 other connections to www.domain.com. It can open another 6 to css.domain.com, another 6 to javascript.domain.com, and so forth, right? So what is the trick here? Is that the browser basically open, instead of just 2 connections, like HTTP 1.1 recommended, they open maybe 18, 24 connections to a single server maybe, because then there's virtual hosting, and the server that actually serves all those resources is a single one, right? Imagine if every single browser that points to CNN.com opens 24 connections to the single CNN.com server. They need to have a lot of hardware, right? So it's not good. But there is another side to this. Not only the clients want to be really fast, but the servers want to be really fast. These are 5 studies that are, they're public and they're pretty famous. They show how important is that the server and the clients work together to provide the fastest user experience possible. Like, for example, Shopzilla. They went in page rendering from 6 seconds to 1.2. They increased revenue by 12% and page views by 25%. Another example, Yahoo they calculated, well, they made tests, and they calculated that for every 400 milliseconds, there was an increase in the traffic on the site by 9%. Okay? This one is Amazon.com. For every 100 milliseconds shaved off every page, Amazon.com makes 1% more revenue. Imagine Amazon.com, they're making $1 million. 1% of $1 million is $1 million. So 100 milliseconds, it's a very short time. It's so short that, for example, when we flicker the eyes, close the eyelids, it's about 300, 400 milliseconds when we do that. Still, 100 milliseconds is something that the human eye and the human brain can detect. I can feel the site is faster, and I want to stay on that side more and maybe buy a little more things, right? Mozilla.org, they shaved 2.2 seconds from the main landing page. They calculated that this turned out to be 60 million more downloads of the Firefox browser in a year, right? So fast HTTP makes money. It's not only a technical issue, it's also a business issue. So if you are in charge of your business and you're thinking, our site works, yeah, it could be a little bit faster, think about this. If it's fast, makes you money, just by doing nothing. I mean, there are studies that prove this. It's not just me telling you, right? So I hope that I carved a dent into your conviction that it's now a good time to consider HTTP2, but let's go a little bit further and try to understand how HTTP2 works and why it is and it has been designed in a way that is so much better than HTTP1. So HTTP2 is now a binary protocol. It's not anymore a textual protocol. is deriving from another experiment that has been made by Google called the Speedy protocol. It's very efficient to generate, very efficient to parse, and it has been designed so, exactly to address all the limitations of the HTTP 1.1 protocol. It's based on packets called frames, and it works in this way. The client, the browser, makes a request. A request is made of HTTP headers, exactly like before, but now they are transported in a packet called, in a frame called headers frame. Of course, the client can also upload data. For example, if you submit a form, so you can send a different frame called the data frame. And then the server just replies with a headers frame containing the response headers this time. And of course, with the content, multiple data frame that contains the content. For example, image bytes or HTML content or JSON or whatever, right? The specification of HTTP2 defines the protocol, but the reality is that the HTTP2 protocol has been deployed over TLS. There's been an important movement towards TLS and making the web more secure. And this started a while back, and then it was really exploded when all these cases with the NSA came up, and you really want to have your communication with the stuff that you do over the internet in a secure way, so that nobody can look at what you're doing. It's a debatable thing, etc. But nevertheless, there is a strong movement for every new protocol that the IETF or the W3C defines to actually go towards TLS. So the reality is that browsers, for example, only implement HTTP2 support over TLS. You cannot open anymore an HTTP-only website with the HTTP scheme and expect that to work over HTTP2. Currently, most of the browsers don't do that. They only support HTTP2 over TLS. This, of course, opens another issue, which is the transparent proxy problem. For example, there are countries, poorer countries, where the traffic that goes, for example, from mobile phones to the internet goes through a caching proxy that makes the user save a lot of money because, for example, it caches a lot of things, so it doesn't have to keep the connection open for that long. And maybe in those countries, they pay it's not a flat fee that you pay for your internet access, but you pay for the time you stay on the phone or for the amount of data. So, however, the group of experts that define HTTP2 is also working on this problem. So, it's known, it's being addressed. However, the protocol itself doesn't mandate HTTP2 so much so that if you build server-to-server communications, then the communication may be totally being clear, okay? It's going to be efficient, it's going to be all the goods that the HTTP2 protocol has, but yeah, you can only, browsers don't support it. Multiplexing is one of the most prominent features of HTTP2. How does it work? It works in this way. The blue pipe is a TCP connection, okay? With HTTP 1.1, the only thing that you can do with this big TCP connection was to send just a single request, this green pipe here, to the server, and then you had to wait for the response on that, right? So multiplexing doesn't work in this way. In HTTP2, you can open this green pipe, send one request, do not wait for the response, doesn't matter. I can open another. I can send another request, open another green pipe, and another, and so forth. So what we get here is basically that we can send multiple requests at the same time. I have a demo in a few minutes, so I'll show you exactly how this works. The other very good thing is that even though this pipe was the first one that was actually requested, the first request that was sent, it doesn't have to be the first that gets returned. The answers from the server can come out of order, right? So, for example, this one was the last one that was sent, but the first one to be returned, because maybe that particular request was very quick to be served. Maybe just the favorite icon that pops up in the browser icon for that tab. and so forth. Of course, the other responses can come up later. There is a request ID. These green pipes are called streams in the HTTP2 parlance, and each stream represents a request and response communication, and each stream has a particular ID. So the server and the client can totally correlate the packets that go back and forth, because each of these packets, each of these frames contains the stream ID. So they can figure out which one goes where. Another very important feature of HTTP2 is HTTP header compression. Now, imagine a normal HTTP request, okay? A normal HTTP request is made of, for example, headers. Headers, a very common header is the user agent string, okay? You may have fiddled with that in order to trick the server to figure out, oh, this is it's a desktop browser, but I changed the user agent string so that you think it's a mobile browser. So that string is a very long string that tells a lot of things about the client, and it's being sent over and over and over. It's a constant that is being sent by the client over for every single request, okay? So it's a waste of bytes that go from your client to the server, and it doesn't provide any additional information every time you send it. I mean, you could send it the first time and then be done with it, right? The same goes for cookies. The server sends down a cookie to the client, and the client says, OK, I need to send this cookie back to you every time I make a single request for this particular domain. So again, the cookie could be really long, like kilobytes long, and it's a waste of time and space and resources. So HTTP2 uses a compression algorithm that makes a typical HTTP request about 600 bytes down to 90 bytes. That's 85% saved. But that's only the first compression that this is capable of doing. The second request comes in a way that says, oh, you remember the user agent string that I sent you before? So I just send you a pointer to that particular information that I sent you before. So the user agent string goes from 100 bytes to 1. Pointer to what I sent you before, okay? Again, let's go to the business case of it. Imagine if you're paying your cloud deployment by the bandwidth, okay? If you're going to save bytes every single request and you make a lot of requests, then it's a lot of money saved because you consume less bandwidth. Another feature that has been introduced in HTTP2 is request prioritization. Why is this has been introduced? Because the web of today is pretty complicated, especially on the client side. We have JavaScript, and we want to interact with the pages that we build and deploy. So it may happen that the browser says, OK, I need to download this request, make a request, download the HTML, start parsing the HTML, and say, oh, there's a JavaScript. I need the JavaScript. Make a request for the JavaScript, download the JavaScript, parse the JavaScript, and then the JavaScript executes something, OK? And turns out that the execution of that JavaScript makes another JavaScript more important to download first before all the other resources that are declared in the HTML. So at that point, you really want to be able to tell the server, hey, I need this JavaScript first before all the other requests that you told me to download on the HTML page, right? So this was a help that or a hint that the client could send to the server and say, hey, I know I asked you this request, but this one is more important now. Not only that, they can also reprioritize, making, OK, I'm asking you this request, start downloading a little bit, and then the client can say, oh, but now it's not important anymore, because I started parsing a little bit, but I have other more important things to do. So rather than raising the priority of other resources, I can lower the priority of the resources that are currently downloading. It has kind of different effects on the servers, so it's not widely supported, this feature, the prioritization, but nevertheless, it's in the protocol. I mean, if you really need it, it's there, and we can use it. The other astonishing feature that HTTP2 introduced is this one. It's called HTTP2 push. And it is about the correlation of HTTP resources that I hinted you a few slides ago. So think about this for a second. Every time we download a page, that HTML page contains references to other resources. Those other resources are secondary resources that are declared in this primary HTML resource. Okay? So it would be really interesting if I can pack all these resources together and then just download them all in one go. Okay? This is how it actually works. Okay? So HTTP 1.1. I have to make a request. I make a request for index.html. Round trip, download the HTML. The browser starts parsing it. Okay. Then we figure out, parsing the HTML, that we need application.javascript and style.css. So let's open two connections now, and let's request those two in parallel. Okay. So another round trip, but this time we do it in parallel, so we download two resources at once. Good. Turns out that while I'm parsing the CSS on the client, the CSS references a background image, for example. So, OK, let me ask that image too, because I need it to render the page, right? So it's another round trip to the server, and it's a very simple page, only 4 resources, not 95. And you know, I already have done 3 round trips to download all the stuff. Imagine if your server is across the ocean, then it's almost 200 milliseconds to go there and come back. So it's 600 milliseconds just to download the stuff, okay, in the optimal conditions. But the server can understand that every time index.html is requested, then what happens next is that application.javascript is being requested, style.css is being requested, and image.png is being requested. Okay? So what it can do, it can say, well, you know what? I can correlate these other 3 resources, secondary resources, to this primary resource and build a push cache where I pack all this information together. Okay? And then HTTP2 comes along, and this is what happens. An HTTP2-enabled browser makes the request for index.html, and the server can say, oh, you're requesting the index.html. I know that you're going to need this JavaScript file, this CSS, and this image. There you go. Okay? Download everything at once. So in just one round trip, I can get my image. That's a 3-time reduction in rendering of this page. Okay? Remember the slides that I showed, the use cases that I presented before? This is basically money coming back to your business. All right? Okay, so these are the main features of the HTTP2 protocol. I really hope that I convinced you to consider HTTP2 a lot more now and say, man, I should go back to my workplace next week. Let's figure this out and let's move our website to HTTP2 because it's money. So, okay, can we do this, though? I mean, yeah, if I go to my work next week, can I actually do this? So it turns out that, yes, you can do it. You can already do it. Because HTTP2 is now a final specification. It's an RFC. It's a standard. And browsers have already implemented it. Like, for example, Firefox since version 34. We're now at 41, I think. Chrome since version 38. We're now at 46 or 47, something. Internet Explorer is from version 11. We are now at 10, so it's so it's already there. I mean, these two guys cover more than half. The cool thing is that these two guys, Firefox and Chrome, also cover the mobile devices. So your mobile devices are already HTTP2 enabled from day one. You're not speaking anymore HTTP1, and you're not speaking anymore old protocols. You know, phones are super up to date. And it's already there also on the server side, because you go to twitter.com, you go to Google, you go to every major website, and it's already HTTP2 enabled. Like, for example, our own website, webtide.com, we run Jetty, and it's HTTP2 enabled. our own website is served via Jetty. The Devoxx website, which is the news and stuff and related to the Devoxx conferences, it's on HTTP2 using Nginx. Okay. And the list is growing as we speak. I mean, sometimes I really go to certain sites, and the day before they are HTTP 1.1, and the day after they move to HTTP 2. And there is a reason they do this, and the reason, again, is what I showed you before, is business, because it's better, because the protocol actually is designed from the ground up to be a better protocol for today's web. All right, so great, so I can do it, but what do I need to use to do it? So do I have the tools and everything? Well, it turns out that yes, you do. For example, curl, Wireshark, they support HTTP2 already. And this page is the page of the HTTP2 specification. In this page, there is a list of implementation. There are 35 plus implementation in basically every language you can think of. It's like Java, C, C++, Go, Node, Erlang, Haskell. I mean, every major language has an HTTP2 implementation. So you don't have to worry the technology that you're using. There are very, very good chances that you can deploy or you can use HTTP2 in your business. What about the Java side of things? Where are we? Okay, because this is most important for us. Well, there are very good news for the Java side of things. That, in particular, if you're deploying WARs on your web applications, you have to make 0 changes to those. You take your WAR you compiled yesterday, you change your infrastructure to support HTTP2, you deploy your WAR, done. Done. There's nothing more that you have to do, okay? So existing web application work out of the box, no problem. What about all the features that the HTTP2 protocol provides, multiplexing and push and whatnot? So the push functionalities are provided by the server implementation. So for example, we provide the push functionality in Jetty. So if you deploy your web application into Jetty and you enable HTTP2, you can have HTTP2 push for free. You just configure Jetty, done. Like in the same way you configure a data source on your web application and stuff. Now you configure the server, here you configure HTTP2, and Jetty will figure out the correlation between resources and start pushing for you, making your website so much faster. There is a possible action that you may want to take, maybe in the future, there's no hurry to do it, which is removing the old HTTP1 best practices like domain sharding or image spriting and stuff. These are not needed anymore. So, well, you can remove it. You don't need all this complex configuration. Or just imagine putting all your JavaScript into a single humongous JavaScript file, because why you do that, right? This is like resource coalescing all these resources together. You have 30 JavaScripts, but what you're actually doing, you're putting them all together, concatenating them all together, and then serving them as a single file. Why are you doing that? Well, exactly because the HTTP 1.1 protocol would have made 20 requests to your server, and it doesn't have 20 open connections to make them in parallel in just one round trip. It would have done 6 back, 6 back, and so forth, right? So the trick is, okay, if I concatenate them all together, then I just make one, right? So that's the key thing. But it's not needed anymore with HTTP2, because you can make as many requests as you want in parallel in the single TCP connection that you have opened. So, not need. HTTP2 compliant Java server require JDK 8, but of course, who uses here JDK 7? It's end of life. We are all happy in JDK 8. We've heard at this conference a lot of good things about JDK 9, so it's good. The real reason behind this, constraint is that in JDK 8, there are the strong TLS ciphers that are needed for the HTTP2 to be HTTP2 compliant. Actually, the HTTP2 specification mandates that you have to use very strong ciphers for HTTP2 to work. So this is the reason. These strong ciphers, they're not implemented in JDK 7, just because there's an evolution on the strength of the ciphers, and every JDK gets a refresh, and the new ciphers and the old one, or that are maybe vulnerable, gets deprecated and so forth. So it's natural. There's also a good thing. Server 4 is going to support HTTP 2. The Jerry team is actually very involved with the HTTP servlet expert group. So we are actually proposing, because we are leading the way in a way in this field, we are actually proposing to the expert group modifications to the API in order to support push. For example, how about doing a programmatic push? Inside your application, you know that these two resources are correlated. You can serve one and then tell the container, hey, by the way, also push this guy with it, because I know, okay? But, basically, it will be a backwards compatible API. It will just work. Other efforts that are underway are these. JEP 110 will provide a standard HTTP2 client API for JDK 9. This is already under discussion. Michael McMahon is the lead for this effort, and it has already published a proposed API. So if you're interested in contributing this, or if you're a heavy user of HTTP clients and you really don't want to go and use Jetties, use Apache's Commons, or use a Sync HTTP client, or whatever you really want, if it was in the JDK, oh man. Well, it's going to be in the JDK, so if you're really interested in this, subscribe to NetDev at openjdk.java.net and contribute to these discussions. There's a technical requirements which is fundamental for HTTP2 to work, which is, it's called the TLS ALPN extension. I'm working, because I am the one that implemented it in Java, like for Jerry and for other projects to consume. I'm talking with the security team leader at OpenJDK, and this is basically at a point where we are going to have ALPN in JDK 9. The API has been designed already, and it's it's just waiting for that to be implemented in the JDK and perhaps in the servers as well. So in the Java world, what are the servers that actually support HTTP2? Well, of course, Jetty. We have a server that fully supports that, but we also have the client. So for example, if you want to do server-to-server communication, you can have a Jetty HTTP2 client on your web application that talks to a server, another server in your data center. Okay. Of course, we are live now. Our website is running HTTP2. Perhaps it's 1 year or something, and before that we were running it on Speedy. So we have a lot of experience on the problems and the tricks and what you need to do to deploy this. Netty also supports HTTP2. Undertow, it's the servlet engine for by Red Hat behind Wildfly. It also supports HTTP2. And on the client side, for example, for Android, there is a client called OKHTTP that can actually be used to talk HTTP2. Well, I have to say that also the Jetty client, well, no. Jetty client requires JDK 8, which is not yet supported in Android. So yeah, OKHTTP client is the way to go for now. But eventually it will come as well. So just to give you a simple example about Jetty, the HTTP client, we do have an HTTP client, okay? It's been there forever, basically. It provides a high-level API. So it provides you a mean to say, I want to request this resource, URI, with this method, get. Okay? That's a high-level description of what you want. But the way you transport this information from the client to the server can be different. It can be in the HTTP11 format, and then you configure your HTTP client in this way. Or it can be in the HTTP2 format, and then you just change the transport while you're configuring HTTP client, done. So this is a one-line change that you have to do to switch from using the Jetty HTTP client from HTTP11 to HTTP2. Okay, so what is the recommended deployment that we suggest on this? Well, this is what we recommend typically. And this is very important, but we will have time for questions. So typically what happens is that the browser will use TLS and HTTP2 to talk to the server side, okay? Because the TLS implementation is Java, is a bit memory hungry, it's not really that efficient, there are much better implementation. What you really want to do is you want to offload the TLS onto some kind of device. Here we totally recommend Haproxy to use it. We recommend Haproxy because it has a very fast TLS offloading facility. It's a proxy, but also a load balancer, so you can load balance to different servers. And the good thing is that it's one of the only proxies load balancers that supports talking to the backend using HTTP2, okay? It's one of the very few for now. So if you're already using a proxy, you're in a very good shape. If you're not using a proxy, you're using maybe, for example, other typical deployments are, I don't know, instead of a proxy, you have Apache in reverse proxy mode or Nginx in reverse proxy mode. Then these two will work. It will speak HTTP2 to the client, but we speak HTTP1 to the server, to where you actually have your business. So you will not be able to figure out as well as you can do in this scenario, for example, HTTP2 push. That will be disabled because here is where you know what you have to push, but the HTTP1 protocol that you're talking here doesn't allow you to tell you that you want to push things. So this one is the recommended deployment that we provide. There are other big players that are rushing to update to HTTP2 in this area, in this particular area. For example, all the providers for load balancers and proxies and stuff, and like F5 and Cisco and whatnot. So they're rushing to it. They're still a little bit behind, so you really have to keep an eye open here, depending on your infrastructure. Demo time. So let me show you actually, because I spoke a lot and you have to trust me, but there's nothing better than actually showing you things. And let's see how it works. So, okay, cool. So this is the demo that I wanted to present you. What I've done, I have slowed down artificially the localhost interface in order to simulate a 200 millisecond delay between requests. If I was requesting a request to a server that is on the other side of the ocean, okay? This is because otherwise the localhost interface is so fast that you don't see any of the good effects or the bad effects of HTTP1. So let me go and click on the HTTP1 link. The page that is going to show up is a page that is composed of other resources, small tiles of images that compose a bigger image, okay? This is a simulation of how a web page is made today. A page is made of secondary resources, the 95 that we saw for CNN.com, and this one only has 24. And so it's a kind of a small page, but let's see how it behaves in HTTP1. So I click. Oops, that was fast, because I didn't slow down the localhost interface. Okay, so let me go back here for a second. Let me go here, kill this, do this, and restart the server. And let's go back here and reload this page. OK, we're now good. OK, so click. OK, so this image, have you seen what happened? I clicked, and then what happened is that a few images were coming down, and then suddenly the other images was coming down a little bit faster. OK, that's a feature of the TCP protocol called slow start. So every time you make a request, there is a very small bandwidth that TCP allocates for you. And the more requests you made, the more traffic you made on that connection, the more TCP enlarges this window to say, OK, now you can use a larger bandwidth and a larger bandwidth and so forth, right? So at the very beginning, connections are cold. You have to warm them up in order to use them at their full potential. And so much so that if I refresh this page, yeah, OK, maybe timed out. So I refresh it now. You see, it's kind of a little bit faster, OK? Because now the connection to the server is hotter. And so if I refresh this page, is faster. So let me show you how it looks like if I go to the network monitoring here, and I just reload the page in this way. OK. There you go. This is the profile that you get when you load a page with dependent resources, OK? So yeah, you get the first request is the main page, the main HTML page, OK? And then you have 4 requests here, 4, 4, 4, 4, OK? In this particular case, Chrome has opened only 4 connections to the server. It typically opens 6. I don't know why for the demo open only 4, but it always happens. But this is a typical profile. Okay, it's scaled waterfall that you can get with HTTP 1.1. And this is what you have to, I told you before, right? 95 resources, you open 6 connections, make 6 requests, wait for them to come back, make another 6 requests, wait for them to come back, and eventually you can render the page in 1.48 seconds. All right? OK, enough about HTTP 1. Let's try to see how does it change for HTTP 2. OK, so I click here. It's immediately faster, OK? But this particular request was not even, was the first request of the HTTP2 kind, all right? So the server, in this case Jetty, didn't know what was correlated with the primary resource. It didn't know that there were 24 resources correlated to the first one. So you could still see the fact that the bigger image gets created by other smaller images, right? But now Jetty has this information, has built a cache on the server side, and it will be able to push resources. And you can see here, look at the difference in there's no anymore this squared sequential waterfall. Now all the resources that make the primary image have been sent 24 requests at the same time all together. They're all starting at the same time, you see? They take more time. Well, this is maybe just because of network, how Chrome is implemented. But the interesting thing is that they start all at the same time here. I have a page with 24 resources, download the primary page, parse the page, figure out I have 24 resources to download, boom, them all to the server, back, all right? I don't have to wait for the 6 to come back and then make another 6 and whatever. So what happens if I reload this image? If I reload this page? Oops, so let me try to, you can't see it, but I'll try to figure it out. So what happened? The interesting thing here is that Jetty now had the knowledge that those resources was correlated. So you can see those requests are actually here, all right? At the very top, there is no traffic at all. What happened here was this. Jetty was saying, OK, this is a request for HTML, the HTML file, but I have to push you back also the other 24 images. It did so here. OK, so all the other 24 requests, the browser said, hey, I need this image. Let me look in the cache. Oh, it's here. Pick up from the cache. Oh, I need the second image. Oh, it's in the cache. Pick it up. So there's basically no traffic in there because all the traffic has already been done. There's no latency, nothing. So if I refresh this page again, click, you see that there's just a small flickering. Now let me close this for get rid of fat, but click. You don't see, I mean, it's immediate. This page is being reloaded, but you don't see it because it's so fast that, that of course, you don't need it. So let me go back to HTTP 1, just for sake of, right? This is the difference that HTTP 2 makes. And even if I reload this guy, I can still see that the page is being rendered slowly. Okay, go back to HTTP 2, boom. See the difference? This is what makes you money. Right, let's resume and go to the conclusions and then to the questions. Okay. Demo time. Conclusions, all right? So, good thing is no changes for web developers. Super cool. The Servlet API will be backward compatible. Frameworks will be able to leverage the new HTTP 2 features. You don't have to do domain sharding, spriting, hacks, best practices, all gone. It's, you know, the new protocol has been designed from the ground up for today's web, not for 20 years ago web, right? So JDK 9 will support HTTP 2. Yesterday we spoke with Mark Reinhold. He actually said, well, the main feature of JDK 9 is going to be, of course, Jigsaw, but you know, kind of the second in the list is probably going to be, or certainly one of the most important is going to be HTTP 2. And this is because you know the world is moving there. So, and it's really important. I show you why. So developers, you're cool. Nothing to do. Go back to your next week work job and you're good. Deployers, though, a little bit more work, okay? So if you manage the data center or you're in charge of, you know, deploying things and stuff, you have to pay attention to a couple of things. So first one is TLS everywhere. If your website is not using TLS, then you have to buy a certificate. Okay, and you have to renew the certificate every year, every 2 years, whatever. So you have to put in place a process in your company that figures out this renewal thing about the certificates and keeps them up to date. You have to upgrade your server container. If you're using Jetty, you're good. Just update to 9.3 and you're good. If you're using Undertow or Wildfly or whatever, Wildfly 10, I think, it supports for HTTP 2, you're good. If you're using Tomcat, you have a problem. Well, it's not that you have a problem, but the support for HTTP 2 is going to come in Tomcat 9. So, which is still a lot in the future, and there's no clear date of when it's going to be available or something. There are, I don't know, I mean, I follow the project in a bit because I'm interested in HTTP 2, but if you want more information, you really have to drop an email on the Tomcat mailing list asking what are the plans for Tomcat to support. Nginx supports HTTP 2, Apache supports HTTP 2. The only thing is that I showed you before is that they support HTTP 2 on the front side, but not on the back-end side. So if you really want to deploy your website to its fullest, you have to have HTTP 2 everywhere, like end-to-end HTTP 2. That's the best possible solution. So recommended configuration for you guys is client, hub proxy, TLS offloading into a proxy, and then Jetty in the backend or Wildfly or whatever you like. Take a look at your network infrastructure. If you're deploying Cisco, BGP, F5, or other network elements in your infrastructure, firewalls, etc., well, take a look at how they work. Load balancers as well, because they need to support. They need to understand HTTP 2. They need to understand that what they're going to come out after they decrypted the data is not text, is not HTTP 1.1 text, is going to be binary HTTP 2. So they need to understand that, because if they don't, they will close the connection and your website will not work. So, final slide. I just want you to take one thing out of this session, which is HTTP 2 is there. Please do use it. There is a very good technical reason to use it, which we talked about, but there is also very good business reasons to use it. So, thank you. So I have like 10, 15 minutes of questions. If you want to questions, I think there are microphones at the middle layer.
Yeah.
Yep.
Do you know if Spring Boot supports HTTP2?
Yes, it does, because there's Jet inside. Well, Spring Boot supports other deployments mode, but one of them is with Jetty. So if you choose that one configuration, then yes, it's going to support HTTP2. More questions? Yes. I'll repeat it.
The first question is caching on the browser. I saw that when it makes a request and there's push mode, all the resources get pushed back to the browser, regardless of the fact that the browser might have cached them, on a prior
Yes. Okay. So the question is, the server is pushing resources down to the browser, but the browser may already have those resources cached. What happens in that case? Okay, so the HTTP2 protocol, provides a way for the browser to cancel requests. And especially, for example, it can cancel pushes. So experiments that we have done and others have done is that the bandwidth is not a problem. So even if the server pushes down more information that the browser already has, it doesn't matter much. What matters most is the latency. So even if you're pushing more data that maybe the browser already has, doesn't matter much. So the case could be that the browser receives the information, say, hey, I'm going to push this resource, okay? So the HTTP2 protocol sends a kind of an initial frame called push promise that arrives to the client, and the client says, oh, you're going to push me /main.css, okay? But I already have it. So the browser can just issue another frame that is called reset stream, telling the server, I don't want this, okay? Now, it could be that the server has already written the main.css file, so it's in flight. And so at that point, the reset will go to the server and say, hey, I wanted to reset the stream, but it's already written, so nothing to do. But if it's not already written, then the server will stop sending data. So it works in a very good way. So let me ask you, for example, by raising hands, who has had the use case of sending a request to the server, but then being able to cancel that request and say, click, and then, no, I was wrong. I want to cancel this request. Who has had this case? OK, many people. OK, so HTTP2 supports this case, which was not supported in HTTP1. There was no way in HTTP1 to do this. In HTTP2, there is a way to do this because the protocol itself supports a mechanism for letting the client send a message to the server saying, I don't want this request anymore. Okay? It's called reset stream, like I just said. So this is going to be supported as well. Now, it has to surface from the protocol to the API that you can use, for example, in JavaScript. But it's going to be there because it's a very interesting use case. So, second question.
Okay, the second is about the HTTP client.
Yes.
We saw that you can specify a different transport, like HTTP2. Does it fall back to HTTP1 if the server does not support it?
OK, so the question is, we have seen that the HTTP client can be put in a mode where it speaks HTTP2. Does it support a fallback to HTTP1 if HTTP2 is not supported? The current answer is no. It's in the plans. Typically, when you use the client, it's typically done for server-to-server communication. And at that point, you know that it's supported or not. So you typically know. If you don't know, what you can do is you create 2 instances of HTTP client, one configured for HTTP1 and one for HTTP2, and then you try them both. But it's in the plan. It's something supported. It's not that simple. There are a number of technical details that need to be figured out, but for now, it's not supported. Other questions? No, we're cool. So thank you for coming, and use Jerry.